Hello everyone, it has been a great event since now, and thank you for accepting the talk. I am Zeki Seskir. I'm part of QWorld, and also I'm a PhD candidate in physics department in METÜ, Turkey. And today I will talk to you about the landscape of academic literature in quantum technologies. Let me just take this into full screen. Can you see it? It is changing, right?
Yeah, we can see it.
Okay.
Yeah.
Thank you. So this work has been recently published, but it is not quite old, but the data goes back to 2019. And I will very briefly go over the outline, the background, methodology, what is bibliometrics, our data set, keyword analysis, and I will not go deeply into the burst detection and core corpus. I will go to burst detection, but not the core corpus part. And if you have any questions regarding this work, you can always email me or write through Discord. And well, the motivation of this work is actually, I think, more relevant to what you are doing here. I was curious about, what are the trending topics in the literature, because I am a PhD candidate, and during your PhD and also during your master's as well, you want to find a, let's say, hot topic that will still be relevant for quite like 5 years or 10 years. And I was looking for methods to, predict what will be important in the field. And I also have this second master's degree from Science and Technology Policy Studies, and there was this course. The first time it was given by an instructor that just returned from NASA Astrobiology Institute, and the course was bibliometrics. And I thought that we could replicate our instructor's work for quantum technologies. And here you can see that it has been on archive since 2019. So what is bibliometrics or scientometrics? They are interchangeable. It is basically it's an emerging field, or it's own discipline. You can say it's its own discipline right now. And it is the study of academic literatures or any kind of literatures through certain quantitative methods, like citation analysis. You look at the network of co-authors, countries, collaboration networks, and you can do a lot of things using bibliometric tools. And one of the difficult things about bibliometric research is that determination of sample size and formulation of the search query. So if you do not formulate your search query right, you can get a lot of junk. So think of it like this: you just type quantum and you get everything that is given to you through Web of Science or Scopus or Google Scholar, and most of the things will not be related to quantum physics, right? So you have to very carefully formulate your query. But the good part of this kind of research is it is actually not the analysis part, but the data gathering part is really reproducible and replicable. So you can, by using our queries, go to Web of Science, go to Scopus, and repeat this entire work by yourself. So what we did was we initially formed a query, we did some analysis, we searched, found some experts, asked their opinions and feedbacks, new query analysis and expert opinion. And both software tools that we used, VosWeaver and SciSquare, are free software tools. You can just go to the websites and use them. So this was our initial search query, and this was the final search query after expert opinion feedback. And you can see the numbers here. I'm giving you these numbers because if you use these queries on Web of Science and look at the articles and proceedings for March 2019 and articles for June 2019, you will find these numbers. And you will find the same articles. There are some redacted articles, but the number will change like 5 or 10 at most. And what we found was that there was around 50,000 articles in June 2019 in the academic literature of quantum technologies. And there were more than 495 journals with 5 or more articles. Here you can see the number of articles, and I mean, it is clear that the trend is upwards. It is increasing rapidly. But also you can see here that the collaboration is also increasing in the field. And as of 2013, the mode of number of authors per paper is 3, which means that most of the papers here after 2013 has 3 authors. So a single author paper, or even a collaboration between 2 authors, is becoming a thing of the past. The field is becoming highly collaborative as time progresses, and here you can see that even for papers that do not have more than 10 authors, the trend is upwards. So it is not like there are these papers and there are certain papers with 50 or 100 authors that is causing these spikes. The trend is very clearly upwards. And this is our initial keyword clustering. We sent this to experts for feedback, and after the final search query, we have found this kind of clustering. And here you can see there are 3 clusters. The colors are arbitrary, you can change the colors. But what we have found is, as we analyzed it, this one, or the red cluster, is more related to physical implementation of these systems, or these, let's say, approaches. And the blue cluster is more on quantum communication, quantum cryptography, and like single photon sources, single photon related research. And the green cluster is more on computation and theory. But if you include all the keywords, so for this version, we only use the top 60%. And if you include all of them, there is a 4th cluster emerging. And this 4th cluster is more related to newer topics like quantum thermodynamics and open systems and many-body systems. And again, here you can see that we use the clustering of terms occurring more than 200 times in the set. And later we went to something called burst detection, which was the part that I was really interested in. We use Kleinberg's burst detection algorithm. You can check the paper. So the beautiful part of this algorithm is that usually in looking at things like burst detection, people use, or previously they used, frequency analysis, like how many times the software encounter a certain word, and look at the frequency of words or the change of frequency. But this algorithm actually looks more like the first derivative of the frequency analysis, but also with certain parameters, so that it does not include, let's say, unnecessary bursts or things that doesn't seem quite like proper bursts. I will explain what I mean by this. And here you can play with a certain parameter. Again, the name is arbitrary, and you can find different keywords. So this is for the lower parameter analysis, which means we only looked at higher bursts if the burst is stronger. And you can see from 1995, there's quantum computation, which is not, it's not surprising. And then entanglement, quantum computer, teleportation, quantum computing. But as time progresses, you can see that topics emerge, newer topics emerge. And things like quantum discord and correlations become important. And this is for a higher parameter analysis. You can see the full list in the paper. It is open to the archive. And actually, we only put here the ones that were still bursting as of 2019. Maybe you run the same analysis again. Some of these will disappear. But here you can see really hot topics as of 2019, like quantum image processing, ADS-CFT correspondence, open quantum systems, and here you can see a comparison between frequency analysis and burst detection. So this is just pure frequency analysis. Here you can see that, for example, quantum teleportation is not bursting, right? It is going steady. But these others are bursting. So you don't see quantum teleportation here, but you see the other ones like quantum coherence, quantum simulation, quantum annealing. And again, here, if you look at quantum computing, you see a huge burst here. I don't know why that is. There are certain speculations about that. But as you can see, it is not related to, I mean, the size, the weight is related to the frequencies here, but not that much. It is more about whether the topic is bursting or not. And there is this highly cited articles part that is provided by Web of Science. And here we have found around 800 articles, and we checked the so the highly cited articles provided by Web of Science is not just articles with most citation, but articles with most citation that acquired those citations in a very brief amount of time. So they are really hot articles. And we looked at what those hot articles are citing versus what the general literature is citing. And here you can see in both cases, Nielsen and Chung is the first academic work that has been cited by most of the literature. But the other four, I mean, we looked at the top 5 here, but you can see the full list in the paper. The other 4 changes for the academic literature or the general literature, people usually cite the cornerstone articles like Bennett's, Eckart's, Gissin's, and EPR papers. But the highly cited articles or the highly cited set usually cites newer articles. Like this is the Kimball's Quantum Internet article. This is Walraff's Superconducting Qubits, Nayak's Topological Quantum Computation, and Hordejki's Entanglement Measures review article. And we look at the countries, we have found that China, US, and Europe combined are almost the similar number of papers out. And we looked at the country collaboration. Again, we looked at the institutional collaboration as well. You can see the discussions on this in the paper. We have found that usually the Chinese and Japanese institutions collaborate more internally, and other institutions from US and Europe collaborate more in between. And the discussion here is that we can find some valuable insight through using bibliometric tools. So my suggestion to you is, if you are a PhD student, or you are starting your PhD, or you are trying to decide your PhD topic, you should use such tools and check whether there are some topics that you don't know about in the literature. I mean, it takes time to do these kind of analysis, but it takes longer time to do your PhD, and it would be a shame if there are certain topics that you might have be interested in, but you didn't know about because or of one or other reason. And another thing we can say is the bursting topics evolve away from straightforward quantum computation into more diverse areas. And I think this is important because it shows that the field of quantum technologies in general, and quantum information science in particular, is evolving, and it is becoming a field of itself. So it is not just a hybrid interdisciplinary field between physics and computer science and certain types of engineering. It is actually becoming a field of itself, and it is important for the future of this industry and the academic literature. There are no clear winners. I mean, it is important because you always see certain titles in the news like, oh, China is winning, US is winning, EU is winning, and something like that. That is not happening, at least in the literature. And Chinese and Japanese institutions usually collaborate more heavily, and it is acceptable. I mean, it is understandable because there are time zone issues, there are language barriers, etc. So it is not something that is surprising, and you can look at the references. And thank you for your attention. And
Thank
if
you,
you have
Zeki.
questions,
That was really impressive. I see we have our first question, which asks, was the correlation between keyword clustering and geographical location studied?
That's a very good question, yeah. And no, it was not studied, and it is because there is another software that runs that kind of analysis. It is CiteSpace, but I don't know CiteSpace. So the reason that it was not studied, it was not because it is not a good question. It's a very good question, and it's a very good research question. But I mean, I lacked the expertise on that, so I didn't study it. And I think so. If I remember it correctly, there was this one paper that did this, but for quantum cryptography. Specifically for quantum cryptography, what kind of keywords or what kind of research areas were more popular and where. But for the general field, no, it was not studied. That's a good question.